Hello! I gave this talk last week at the University of Arizona. Unfortunately, there were technical issues. The talk was not properly recorded, the talk was not properly streamed, so I decided to record it again. My name is Gabriele, and I'm very excited to tell you about something I'm deeply passionate about. Something I think all of you should know is happening in academia. This is the rise of research software engineering. In this talk, I'm going to maintain that the future of research is code, and research software engineering is a critical component that is emerging in the academic field. I work at Caltech, but today I'm not going to speak on behalf of my employer. I'm just sharing my own opinion. And I spend a lot of time in my professional life and not thinking about code and science. I think about the interaction between software and science pretty much every day. This is partially due to what I do for a living. I work at CLIMA, the Climate Modeling Alliance. At CLIMA, we're trying to build the next generation climate model. And the A in Alliance is really critical here, because it really takes a village to build a climate model. It takes people that are expert in the science, people that are expert in observations, people that are expert in the software. You need atmospheric scientists, a land surface modeler. We have students, we have postdocs. There's lots and lots of people that make CLIMA, and here is just a small subset of all of us. So, as a software engineer at CLIMA, I work with all these people to build and drive innovation in the space of climate sciences. And all these people are brought together, not just by their scientific goal of building a new climate model, but also by software. None of the people that you see here can do their work without software. And I think this is a shared experience. I can bring up statistics showing how critical software is in research nowadays. And there is a big dollar amount, and there is a large statistic, like 91%. But I don't think I need to justify this. I think if you work in the field, you know how it's impossible to do anything without software. And if you work in the field, you probably, and field here is any type of scientific research, you probably know that there is even more than that. It's not just software is critical, but also there's issues with software. There's not much documentation, there's no tested, there's no reproducing is very hard. And once again, I could bring up studies and surveys showing that this is the case. But once again, I'm going to appeal to your experience, because I don't think I need to convince you. I don't think I need to bring up all the statistics to convince you that the state of research software is not great. And I think you know it. In particular, when it's hard to extend software, maintain software, it's hard to reproduce previous results, and there's no documentation, not testing, sharing codes is difficult. All of this places barrier to scientific progress. So sometimes getting to use a new piece of software feels something like this. There's a massive entry barrier to software. And all of this places barrier to innovation and scientific progress. So this is what I want to think about, and this is what I want to discuss today. But I'm not going to frame it like this. I don't like thinking about negatives. I like thinking about what we can do. Because I think that if I take another perspective here, and if I take the perspective, this is a massive opportunity to increase the pace of innovation. Because if we remove these barriers, then research and innovation can be exponential, because we can build upon each other's results and truly make innovation faster and faster in the scientific realms. So in this talk, I'm going to take a few step backs, trying to understand how we got in various places. And the first step back is going to be here. How did we get here? How is it that the state of research software is not great? And I think, to me, the answer is simple. And to get to that, I want to give an example. First, I want to introduce Hubble. Hubble is probably one of the most successful missions ever. Hubble is deeply famous among scientists, among astronomers. It has changed the way we look at the universe. It has taken pictures that are truly part of our culture nowadays. But this is not what we necessarily look at when we think about impact and success in a mission. If we want to quantify impact and success in a mission, maybe we can go on NASA's website and find a chart like this. This plot shows how many papers were published with Hubble science as a function of time. And if you tally all the numbers, you're going to see that there's approximately 21,000 papers in 30 years of Hubble. So this is a big and important impact in the field of astronomy. This is a very successful mission. But now let me put this in perspective. Let me let me frame this in the context of something else. And that something else will be NumPy. Because this, to me, is an opportunity to compare the incredible and outsized input that code like NumPy has in the field of physics and astronomy. In just 3 years, NumPy was cited 19,000 times, approximately 19,000 times, meaning that approximately 19,000 papers made use and were enabled at the end of the day by NumPy. So this is, if you want, a statement of how NumPy is order of Hubble Space Telescope contribution, has order of Hubble Space Telescope contribution in astronomy. And, we can quibble here. We can say, well, NumPy is used everywhere, all the machine learning papers. And yeah, I agree. So if we want to be maybe more fair, let's compare other pieces of software that are astronomy specific. So for example, AstroPy, 10,000 citations in 10 years. Source Extractor, 9,000 citations in 28 years. MC, the Markov chain code, 12,000 citations in 12 years. And the Cosmological Code Gadget 2, 6,000 citations in 17 years. All these software, from AstroPy to Gadget, have Hubble Space Telescope size impact in the field of astronomy. So half a Hubble, quarter of a Hubble for a fraction of the cost. Hubble was $16 billion. I doubt that, AstroPy costs that much to produce. All of this has changed the way we do astronomy. Python, AstroPy, Gadget, they have changed the way we do astronomy. So software, once again, is absolutely critical in pushing our understanding of astronomy and physics and more general STEM disciplines. However, when I look at this slide, what I see is what's not on this slide. And I think there is two big pieces of software that are not on this slide, or two groups of software. The first one is software that we consider so fundamental that we don't even think about it. Archive, ADS, the software that powers our real-time Euler networks, that power our telescopes, that power our instruments. Software is so fundamental that we don't think about it, like NumPy to some extent, FFW, MPI, HD5. There's so much software that is not getting any recognition, but is absolutely critical to the way we do astronomy and the way we do science. And there is a second group of software, even more important in my opinion, that is not on the previous slide. And this is the software that hasn't been developed, software that hasn't thrived, software that was too difficult to expand upon, software whose creator decided to move to something different. There's so much impact that we've missed. There's so much more advancement and so much more innovation that we missed. Something that can be as big as Hubble that is not there. So another step back, how did we get here? How did we get to so much influential and important software missing or not recognized? And I think the answer to me is straightforward. The answer is, software contributions are not valued. And this is true across the academic system, from the founders to the hiring committees, everywhere. We live in the unfortunate reality where telling a student, do not spend too much time on software. This is valid career advice. What matters is papers, is publications, is not software. And then, of course, if this is the system we're working within, this pushes software into people outside of academia. This lowers the quality of research software, and famous people that are no longer in academia might be creator of MC, might be the creator of Pandas, who specifically said that they will drop out of their PhD because they thought that their software contributions wouldn't be valued. So with a lower quality of our research software, also our research suffers, and this makes some people like me sad. So this is why the state of research software is not great. But once again, I want to take another step back. The software contributions are not valued, not because academia is intrinsically uninterested in software contribution or evil or anything. I personally see this as a broader anthropological change in our world at the end of the day. And this, to me, is a reflection of, the new era that we're in, the 21st century. And in my view, the 21st century is a century of software everywhere at planetary scale. In the first part of the 21st century, we got social media, we got being able to talk to anyone around the world with video calls, we got smartphones. Software is everywhere on a planetary scale, to the point that pundits will say that software is eating the world. And I agree with this. Software is eating the world, but not just, our day-to-day world. I think software is eating the research world as well. And here I'm showing an example of that. Here I'm looking at the fraction of papers in astronomy, physics, and earth sciences that mention the word code or software. As we can see, up to 2010, we have about 16%, which is, or 15%, 1 in 6, which is quite a significant fraction. And if we continue this plot, now we're about 1 in 3. I think this is an underestimate. I think most papers, pretty much every single paper, relies to some extent in code or some form of code and software. So here we are in the 21st century. We're ushered in this new era with software everywhere at a planetary scale. And I think academia is just a little slow to react to this and to adapt. So I want to discuss this. I want to tell you about the immune system in academia, in the academic environment, that given this big change, how things have shaped, how things are moving, and what's happening to bring recognition and to react to this software eating the research world. So our story today will begin around 2010. I don't know what cosmic alignment of stars, I don't know what happened, but people already in the first part of the 21st century realized that there is need for better research software. And that led to the foundation of the Software Sustainability Institute in the United Kingdom. The Software Sustainability Institute is housed at the University of Edinburgh, was founded on the premise that helping individuals and institutions understand the vital role that software plays in research would accelerate progress in every field of scientific and academic endeavor. And I completely agree with this. So something is happening now. 2010, there is a software eating the world, software in the research world, and people being more and more concerned with, or at least some people being more and more concerned with research software. And now the first step is the Software Sustainability Institute. A second step comes a little later in 2012, when people in this collaboration met for a collaboration meeting, and a subgroup of people were discussing why is there no career for software developers in academia? Why that's the case? And this was in another beautiful English setting, the Queen's College in Oxford. A group of people were brainstorming, and one of the things that they came up with is the realization that maybe we should start by recognizing those that work on research software. Who's there? Who's out there that works on research software? What's their name? As in, what's their title? What they're doing now? So what they did was they scanned across a bunch of academic jobs and found the software-oriented ones, and found there is all order of like 200 job titles for people that are software-oriented in academia. So this is already like an issue. How can we have career paths if we don't even have a name for this career? So this is how the term research software engineer came to be. Now we can call all these people research software engineers. And agreed upon the name, we can maybe shape a career for research software engineers. So now we can finally answer the question, what is a research software engineer? And at the beginning, the discourse was pretty simple. We have software engineer on one side, we have researchers on the other side, and research software engineers live in the liminal space between software engineering and research. Yeah, that's easy. But then with time, people recognize that, no, it's not that easy. There's more nuance to that. For example, what about the more traditional IT support? People that help you with MPI, HT5, and clusters and so on. Those are also pushing science with their skills. So maybe they're also RSE to some extent. And this kept growing. And okay, there's much more. What about data science? What about managers? What about... So now I'd say I personally like the definition the US RSE takes for this. RSE being those who regularly use expertise in programming to advance research. So with this, then you might be an RSE yourself. For example, if you do computing in your work, if you spend significant time in software, if you're the code wizard, and if this presentation today resonates with you, all of these are good signs that you might be a research software engineer, maybe in disguise, maybe with a different title. So research software engineers, those who regularly use expertise in programming to advance research. So now that we know what a RSE is, we can go back to 2012. What happened in 2012? Well, after that, everything snowballed into a big international movement. 2013, the first UK conference. 2014, the Professional Society. 2015, there was a fellowship from a large institutional funder. 2018, the American Society was founded. 2021, there's many societies. We need an international society. 2024, nowadays, many societies, many people. Here we can see some of the countries representing there. And as you can see, there is a common branding. Not only we all unified under the banner of research software engineer, but it seems also colors and logos are kind of aligned one with the other, which is kind of fun. So this is where we are now. As in, very quickly, in the span of one slide, we moved from, oh, there's a bunch of people in a room, to there's societies in many countries all thinking about careers or thinking about research software engineering. But so what do these societies do? And in my view, the most important thing that societies do is that they bring together people who believe that better software leads to better science. So the community aspect is by far, in my opinion, the most important aspect. And with community, these societies, well, what they're doing, they're forging collection, they have a mentorship program, the collaborations and conferences and much more. And of course, these societies are also there for advocacy, to learn, to spread awareness, to tell about best practices, to share data about success stories, like this group does that, and it was a great success. And also to share resources from technical seminar to more sociological or soft skill seminars, like how to start your RSE group and whatnot. So these societies are community driven, and they're all there to improve research software engineering and life and outcomes and outlooks for research software engineers. And now I'd say that thinking about societies, maybe it's a little reductive, because I think this at this point is an actual movement. It's a movement that is international, and it's a movement that is trying to get recognition for software as a scholarly contribution. It's trying to get reward, recognition, and career paths for those who work on software, and trying to help training and ensure that there's training for people for the best software practices. I really like how this is framed in the Society of Research Software Engineering. This was the UG one. The Society of Research Software Engineering was founded on the belief that a world which relies on software must recognize the people who develop it. And I think, to some extent, this is the key goal of the RSE movement. So, as mentioned, societies do a lot of things. One of the things that they do is conferences. So as we speak today, the US RSE second conference is happening in Albuquerque. And this is bringing together community, advocacy, sharing resources. And this is the second. There's going to be a third. So this is probably going to be a series, just showing once again how this has grown. And there's hundreds of people here meeting in Albuquerque to improve things for research software engineering, to discuss what we can do. And now that we have this, we can maybe look at what happened in UK. The UK had a head start, so what happened there? And I'd say now UK is in a good position where over the past 10 years, many groups were established. There's lots of people in this picture, RSECon a couple of years ago, and most major universities have RSE groups. And the important step in here is that most major universities have RSE group, meaning that they recognize the value of this. And this is, again, fundamentally what we're asking. And what the RSE movement wants is recognition of the value of research software engineering in our modern science. So this is UK. What about US? I'd say US is lagging behind a little bit. A few weeks ago, I developed this code that scrapes the internet trying to find R1 universities with research software engineering departments or units or something. And so, for example, we can see Arizona State University has a RSE group, but this is not super common. There's 10-ish out of 150-ish that have a very explicit RSE department. And say the biggest one is Princeton. Princeton is leading the way in US with an order of like 30 people in their RSE group doing all sorts of things and supporting all sorts of projects in Princeton. University of Arizona, doing good but not great. If you search University of Arizona Research Software Engineering, you find research, software engineering, robotics, analytics, wireless networking. That's not what we are talking about here. What we want is explicit recognition for research software engineering. But University of Arizona is doing some good things, like Cyvers, like the Data Science Institute. They're all promoting values that are aligned with research software engineering. But once again, the key part here is having the recognition for all of this. So now that we have this, there's something else that is happening in the US that is different compared to UK. That is, private philanthropy is very specifically targeting this problem and very explicitly trying to address this problem. These four funders, Schmidt Sciences, Sloan Foundation, Simons Foundation, and Sean Zuckerberg Initiative to some extent, they're all explicitly supporting research software engineering. They all have explicit goals saying, we see that traditional academia is not succeeding here. Let's use our money, let's use our power and influence to do something to support good science. And this is great on one side. This is what allows me to be here. This is what is allowing our group to some extent to be so productive and successful. But this cannot be the end game here. As traditional academic system, now that we've built this quote unquote immune response in change in the 21st century, in this software in the world that we're learning to adopt, I think we have to continue growing and we have to learn how to stand on our own legs. So traditional funders might need a little bit of persuasion, but here I'm here with my first call for action for today, because I think together we can change this. And we can start small. If NSF, NIH, and whatnot will require persuasion, I think if we all do our part, we'll be able to change this. And to do this, you can start helping by being the first one to recognize the value of research software. And do this no matter what your level. If you have influence and you can hire people, use that. You do look at software, don't just look at publications. If you're a grad student, if you're a student, think about this as a career and think about this as something that matters in addition to your paper. All of this together will allow us to change and reshape a little bit of academia. So I'm asking you to be the first one to recognize the value of research software. And now I also want to discuss other projects that are aligned to the goals of the research software engineering movement. These are the Journal of Open Source Software, RMPI OpenSci, and the Software Carpentries. The Journal of Open Source Software, the idea behind this is to use academia to beat academia. The problems that the journal is trying to solve is that software is not easy to cite. Many papers don't even accept software, journals don't even accept software papers. And when they do, software itself is not reviewed as the paper that is reviewed. So JOSS is trying to address these problems by being a traditional journal with properly indexed by reference engines so that people can track citations in a way that is meaningful. And now maybe I can discuss how all the comparison I did before between Hubble and NumPy, they're a little bit meaningless. That's not how we should measure impact, but that's how we immediately understand things. And this is what collectively we should change. Looking at that number, 21,000 versus 19,000, that's not how we should measure impact and contributions. But since we're doing that, JOSS is trying to use the system to give people credit for what they're doing. And in all of this, JOSS is completely free. It's not taking your copyright. It's completely accessible and open access. And if you want to submit to JOSS, it's straightforward. If your code is for science, if your code is open source, and if your code is in a good shape, then you're pretty much done. You just have to write a short paper, a couple of pages where you describe the high-level goals of your code. You don't need any new result. Actually, you shouldn't have any new result. And you can think of JOSS as an advertisement for your work. You already did all the work in writing your code. You don't need to do more work. This is, to some extent, is a way to embed your contribution within the academic system. And all of this happens on GitHub. So you can submit your paper, you can track your review. Review is completely open. And I really like this because the review is not competitive. The review is collaborative. Reviewers are not trying to strike your paper down. They're trying to help you make your code more impactful, more sustainable. So that together we can build code that is maintainable, sustainable, and it can accelerate science. Really like this. And I think JOSS is working pretty well. Over 2016, so 8 years, there is a JOSS published out of 30,000 papers, which is pretty nice. And given the success of JOSS, Jose is being pushed forward as a similar idea to give credit to those who spend time developing open source educational material. So this is still growing, so let's see how this turns out. But the idea is quite similar. So we have JOSS, or Jose, and next we have Pi R OpenSci. These projects are trying to lift the quality of open source software for science through peer review, mentorship, tools that simplify things from Python packaging and so on. So Pi OpenSci and RSEs, they curate high quality packages for the community, and they offer ways to help you make your code better, for example, peer review. So once again, with the goal of lifting the overall quality of our science ecosystem in these languages, R and Python. Next, we have the software carpentries. This is the software carpentries, the oldest initiative in this slide deck. It was founded in 1998 with the specific goal of teaching fundamental coding skills to researchers. Then in 2014, there was also a data carpentry founded with the same idea, but for data science skills. Now they've merged into the carpentries. And I'd say that one of the biggest values produced by the carpentries is that in addition to promoting open reproducible research, they're also building a big community, a global community of instructors and learners. Every one of those people is fully on board with this idea of I hope fully on board with this open reproducible science. And this, to me, when it comes to principles, is what really attracts me to research software engineer. In my view, research software engineer is founded upon openness, collaboration, reproducibility, and accessibility. This, once again, in my opinion, is what makes science science. Science is about building together and finding new ways to improve our lives or improve our knowledge. And this is something that we do together, something that we do openly, something that we do incrementally. So I think research software engineering is doing the same with software. And in this, what I really care about personally is making tools that everyone can use, is removing the need for very highly specialized knowledge about how HD5 MPI or whatever work, and empowering people to do what they want, the science that they want, without these expert understanding or knowledge or this very high barrier to entry in science. And all these ideas, in addition to me, ideas that attract me to science, are also, in my view, largely linked to the ideas of the open source initiative. Open source initiative is built upon the idea that together we can build better. And I think if we go back to our anthropological point of view and what happened in the 21st century, I think this was quickly realized by the commercial sector. How together we can build better. And projects like GitHub, Linux in the cloud, Android, big data, to some extent, many of these were founded upon open source and the idea of collaboration and the idea of together we can build better, as opposed to competitiveness or proprietary or closed source software. So once again, I see a correlation with science itself. So I will take a step and quote more or less Newton saying, "If I have seen further, it is by standing on the shoulder of open source software." And I truly believe that together, by standing on the shoulders of each other's contributions, we can advance science and we can make its progress exponential. So, as I conclude, I have two more things. Number one, I want to give you resources. I think these are some of the key players in the space: RSE, Research Software Alliance, Software Sustainability Institute, Better Scientific Software. Many of these give fellowships, have trainings, have events, have seminars and conferences. So please go and check them out. sign up for what you're interested in. And one of the things I want to emphasize, importantly, is that some of these curate high quality job boards. Like here I have a screenshot for a few weeks ago for the US RSE. And if you ever are looking for a job, you'll see that the signature ratio in traditional job boards like LinkedIn is approximately 0, whereas here is high quality, curated, meaningful roles in the space of intersection between research and software. And this is maybe my most important takeaway for today, especially to the students in the audience. If you're interested in software, there are fulfilling, impactful roles for you. This is something no one told me during my PhD. This is something that has changed over the past few years. And this, I think, is really important. There is space for you. You belong to this community. If you want to be in academia, there's something for you. So, keep that in mind. And finally, I want to renew my call for action because I want to invite you to join us in our mission to push for a research world where code is treated as first-class research output, where software development is recognized and rewarded, where research code is findable, accessible, interoperable, reusable, where researchers are equipped with necessary skills and tools to develop high-quality, sustainable software, and there are meaningful career paths for those who wish to focus on software. And you can help us by being the first one to recognize the value of research software. And with that, I leave my contact information here, and I'll take any question you may have. Thank you.